Okay, we're going to start with Chapter 6. 6.1, Discrete and Continuous Random Variables. Our learning objectives are as follows. I'll give you a minute to read those. I'm going to start you off with an example. We're going to look at my example here. First thing we're going to talk about is the difference between discrete and continuous random variables. Discrete are numbers that are countable, where you can list out all the possible outcomes. Continuous, those values can take on any number in an interval, any value in an interval. All right, we use density curve. Really, the normal curve is the one we've been using. Best example I can think of is if you're just trying to use a shoe versus foot size. So shoe size can be 9, 9.5, 10, 10.5, whatever you want to say. And you can have like 5 shoes that are a 9, 6 shoes that are a 9.5. Whereas a foot size, when you measure them, can come in any length. So that's a random, discrete random variable. That's what we're going to start with, the discrete random variable. And we're going to use Ty Cobb's lifetime average of 366, which is the highest in Major League Baseball. And we're going to talk about a typical game if you bat 5 times. We're going to let X be the number of base hits. These are the probabilities for getting 0, 1, 2, 3, 4, 5 hits. There's the following probabilities. What we want to know is this a legitimate distribution? Legitimate probability distribution, I should say. And that means if I add all the probabilities up, they have to equal 1. And if you add these, this plus this plus this plus this plus this plus this, they do equal 1. So that's how you show something to be a legitimate probability distribution. We're going to make a histogram. We're going to describe what we see using center shape and spread like we always did. We're going to see the likelihood he will get 3 or more hits in any given game. We can use this distribution right here by adding these 3 numbers, 3, 4, and 5, adding their probabilities. We can figure out what's the probability of him getting 3 or more hits. Then we're going to compute and interpret the mean and standard deviation. So we're going to do this on the graphing calculator. Take out my graphing calculator. And I'll go into my list. And I'll see I put in 0 through 5, and I put in corresponding probabilities. I'm going to quit. I'm going to do second stat. I'm going to make sure that the sum for L2, there it is equal to 1. And it is, which is good because that's what we needed. Now I'm going to create, I'm going to go second, y equals, and I am going to turn on the plot, and we're going to do histogram. L1 is our x's, L2 is the frequencies. I went to the window, and I just made it 0 through 6, the scale of 1, 0 to 0.4, because my highest probability was 0.31, and I made that scale 0.1. I'm going to hit graph. And there's my histogram. So we're going to describe that. And if I was looking at that, I'd say it's slightly skewed right. Remember, this is 0, 1, 2. So somewhere in here is going to be our mean. And this being slightly pulled down this way, we can actually calculate it. We're going to do second, quit. We're going to do second, stat, calculate, stat calculate, 1 variable statistics, L1, L2, we're going to calculate. Okay, so here we come up with 2 things, x bar, which is our mean, and sigma x, which is our standard deviation. So in terms of this problem, if I'm going to interpret my mean, I'm going to say if we were to randomly select many, many games in which Cobb batted 5 times. The average number of hits would be the 1.83 right here. And if we want to interpret the sigma standard deviation, if a randomly selected game where Cobb had 5 at-bats, the number of hits he would typically differ from the mean, 1.83, by about 1.07. So he'd be about 1.07 off from the mean. All right, so let's go back and we'll look at the books. I do like theirs. They give a different example. I went to give you one of my own, but they use a probability model that describes flipping a coin 3 times, and they show you all the possible outcomes. And then they go through the probability of them, probability of getting 0 heads, 1 head, 2 head, or 3 head. Then they draw a histogram. And they talk about the probability distribution. All right, and here is the formula for finding how to set up a discrete random variable and how to set up a probability distribution. You have the values and the probabilities underneath them, just like we did. So, and then they talk about the mean being expected value, and they just show you how to do it. And there's the formula, similar to what I did, where you're going to be multiplying your x values times your probabilities and then summing them. And they come up with another one and go through it here and show you. Same thing with the standard deviation. There's the formula. This is all, you can look it up in the book. Calculator will do it. You will have to state how you did all of this, so you do need to understand the formulas. So I just want to quickly go through those. We're going to look at continuous random variables. All right, and the continuous random variable take on all values and interval numbers, as we talked about. So the one that we've been doing is, of course, the normal curve. And they said, all right, if you have a mean of 64, standard deviation of 2.7, what's the probability that a chosen woman is between 68 and 70 inches tall? And it says the height randomly chosen woman has, at that end means a normal distribution with the 64 and 27. And we want to find the probability between 68 and 70. So they do the z-scores. 68 minus 64 divided by 2.7, 70 minus 64 divided by 2.7. We could do this right in our calculator. If you do normal CDF, and you're going to go from 68 to 70, it'll give you the exact same values. We've done it before. So, last thing I want to look at is that we'll do escape. And so you know where it is in your calculator. You're going to go normal CDF. Ooh. No, why did I close it out? Who knows? So last one, if I do stat, calc, no, bars, normal CDF. And I'm going to go from 68 to 70. And our mean was 64. Standard deviation 2.7. And the probability, it's between 0 and 68. You had about a 5% chance 5.6% chance. And that's it. Hope you enjoyed it. You'll have the notes to go along with this.